Okay, 8.4, Law of Cosines. Example 1, triangle ABC is not a right triangle. How can you use a cosine ratio to write an equation relating the side lengths A, B, and C? Okay, so the first thing I want to do is create a right triangle. I'm going to drop an altitude down. It's going to create a 90-degree here. We'll call this D. So if we had our original side A here, we're creating two segments. I'm going to call this X, and then we will call this A minus X. Okay, and then we would use our Pythagorean theorem to solve. So I could set this up. Our hypotenuse is our C squared, and that would equal our A squared. So I would take A minus X squared. Didn't name my altitude, we'll name it height H, plus H squared. Okay, so I plugged in that triangle into Pythagorean theorem. All right, I'm going to factor out that square. Okay, so if I'm looking at triangle ACD, so triangle ACD, I can use Pythagorean theorem on that, and I would have B squared equals H squared plus X squared. Actually, I'm going to flip that around just to make it a little bit easier to recognize what we're doing. So I would have X squared plus H squared. Well, I can see X squared plus H squared is the same as this X squared plus H squared. So I'm going to take the B squared and plug it in for that X squared plus H squared. Okay, so I have 2C squared equals everything else, AX minus AX. I'm going to end up with 2AX. Okay, here's where I'm going to plug in the B squared. So I'm taking this X squared plus H squared, which is the same as this, and I'm plugging in my B squared. Okay, I also know that the cosine of C is the adjacent over hypotenuse, which would be X over B. I can rewrite that by dividing, or by multiplying by B. And I can put it in terms of X. So I'd end up with B cosine C equals X. Now I can take this, which is X, and plug it in here for this X. Let's go ahead and do that. So C squared equals A squared minus 2A. Plug in this B cosine C plus B squared. Okay, I'm just going to rearrange terms. So I'm going to take this B squared and bring it right here behind the A squared. Okay. All right, so our try it. We want to write an equation for A squared using the cosine A and B squared using the cosine C. So similar to what we did in our last one, we're going to write this in terms of A squared and of B squared. Okay, so find a squared. Okay, instead of doing all the work that we did in our example 1, we can just take what we have already kind of established and rewrite our a squared. So a squared, we would have b squared plus c squared minus 2bc cosine a. Okay, our b squared, we would have a squared plus c squared minus 2ab cosine b. Okay, again, our last one we did for our c squared, I'll go ahead and write it over here as well. We've got our a squared plus b squared minus 2, oh, this should have been, hold on. This should have been 2ac cosine. 2ab cosine c. Okay, so the only thing that's changing with these, so we have our Pythagorean theorem, so this right here is our Pythagorean theorem, essentially. And to that, each time we are subtracting 2 times BC, which we have BC here, and then cosine whichever angle, so A. Okay, and we do the same thing for each of them in terms of each of them. All right, so we have our law of cosine, that's what we just established. Move on to example 2. We want to find BC to the nearest tenth. Okay, so we are looking for BC. So BC squared is what we're looking for. This one right here. We have its opposite angle and we have the other two sides. So our other two sides are 8 and 10, so we'll plug that in for the other side, 8 squared plus 10 squared. Then we subtract 2 and we multiply it by the 8 and the 10. Then we'll have our cosine for the angle opposite the side we're looking for 57. Okay, I'll plug all of the right side into my calculator. So I'm going to end up with BC squared equals 76.864. Take my square root of both sides. So I end up with BC equals 8.8. All right, do the same thing for DE. So we're looking for this side. We'll set it up DE equals the two sides I know squared, 6 squared plus 8 squared, minus 2 times the two sides we know, 6 times 8. And then it's cosine, whatever the angle is opposite what we're looking for, so 62. Plug all of that right side into the calculator. Oh, I should have a squared there. Plug all the right side into the calculator. I end up with DE squared equals 52. Take the square root of both sides. So DE is going to end up equaling 2 square root 13, or approximately 7.2. GH, set it up for GH. Plug everything on the right side into my calculator. Square root. So GH will end up equaling 24.8. Example 3, the optimal tilt for Keenan's solar panel is between 58 degrees and 60 degrees to the horizontal. Has Keenan placed his solar panel at an optimal angle? Okay, so this angle is the angle that we're looking for, and we're trying to make sure it's between 58 and 60 degrees. So we're going to set up our law of cosines. Okay, so I'm going to set this up as 19 squared, because that is the side opposite the angle we're looking for. So 19 squared equals our other two sides squared. So 18 squared plus 20 squared. Subtract 2 times the two sides that we just had, 18 and 20. And then cosine the angle we're looking for, P. Okay, so 19 squared, I'm going to end up with 361. The 18 squared plus 20 squared, I'll end up with 724 minus the 2 times 18 times 20, which will give me 720 cosine P. I need to subtract my 724 over. That will leave me with negative 363 equals my negative 720 cosine P. Divide both sides by the negative 720. Okay, that's going to give me 0.5042 for cosine P. I want to find that measure of angle, so I'm going to use the inverse cosine. So cosine negative 1. And that will give me 59.72 degrees for my measure of angle P. All right, our try it. We want to find the measure of angle X. So we're trying to find this angle. We have its opposite side, so we're going to start with that. 4 squared equals the other two sides squared. Minus 2 times our two sides cosine X. Okay, do my calculations. Subtract my 85 over. Divide by the negative 84. Take the inverse cosine. And I'll end up with 34.8 degrees. Next one, we want to find the measure of angle P. So I will set it up. So the opposite side of our angle is 13. 13 squared equals our two other sides squared and added together. Multiply by the two sides we just had on this side. And then cosine the angle we're looking for. Okay, do our calculations. Subtract my 185 over. Divide by the negative 176. take my inverse cosine. And I'll end up with 84.9 degrees. Example 4. The district ranger wants to build a new ranger station at the location of the fire tower because it would be closer to Bald Mountain than the old station is. Is the district ranger correct? Okay. So we are going to create a triangle here, and we want to find the missing distance. So we're going to set this up to find our missing distance for the side that we don't know. I'm just going to call this side X. We're looking for that side X. And I'll set it up. I'm going to take the two sides that I do know and square those. Subtract 2 times the two sides we just put. Cosine the angle opposite the side we're looking for, 49 degrees. All right, plug all of that right side into my calculator, and I would get x equals 2x. I should have a square there. Need a square on that. Okay, so x squared equals 2.512. Take the square root. So x is going to equal 1.6. Okay, so the new ranger station is 1.6 miles. So the new ranger station would be closer. Okay, try it. Assume a path is drawn from the fire tower to Bald Mountain. What is the angle the new path forms with the old path from Bald Mountain to the ranger station? Okay, so we are looking for this angle of measure. We just found that this side is 1.6 miles. So now we can set this up. We're looking for this angle, so our side is going to be the 1.4. I'm going to square that, set it equal to the other two sides squared and added together. Minus 2 times those two sides again. Cosine the angle we're looking for, so I'm going to name it x. All right, start doing calculations. 1.4 squared, I'd get 1.96. 1.6 squared plus 2.1 squared, I will get 6.97. And then minus my 2 times 1.6 times 2.1. I would end up with 6.72 cosine x. Subtract over my 6.97. That will leave me with negative 5.01. Divide by my negative 6.72, which will leave me with 0.746. I want to solve for this angle of measure, so I'm going to take the inverse cosine. So I'm going to get a measure of 41.8 degrees.